A lot of people here. Well, thank you all for being here. So 2 years ago, I gave a talk about Laravel design patterns on Laracon EU. Then I spoke about 4 different design patterns. Today I'm going to do 3 other design patterns, so we're diving more into design patterns. But let me first introduce myself. I'm Bouman. You can follow me on Twitter, GitHub, and Laracast. Laracast has been like the big thing for me. That's my way to contribute to the community. So that's my way to giving back to this awesome community. And I just love to help others. I work at Enrise. We develop high-quality internet applications. And we're a self-steering company, so if you want to know more about that, just talk to me after. But let's just talk design patterns. So Laravel itself comes with a lot of design patterns. So let's first answer the question, what are design patterns? Design patterns are solutions for common occurring problems in software. So it's a description or a template on how to solve a certain problem in a different situation. So Laravel has a lot of design patterns, and they're all built into the framework. So these are a few of them. These are the most common one in the framework. And some might be familiar to you, and some might not be familiar to you at all. So last year I spoke about these design patterns. Today we will focus on a bunch of different design patterns. And we're going to look into the Singleton pattern, the observer pattern, and the bridge pattern. So let's start with the most used pattern in Laravel, which is the Singleton pattern. So the Singleton pattern is a creational pattern. And it's all about creating objects for you. So it's hiding the logic to create that object for you. And it's hiding that behind classes. So you don't really care how that object is created as long as it's created for you. So you can reuse that. So this solves the problem of complex initiation of objects. So let's start with an abstract example for the Singleton pattern. So there's going to be a lot of food. So you're going to be hungry, and then there's another talk, and then there's lunch. So just be prepared for it. So please raise your hand if you ever made a pizza. See, everybody made a pizza, right? Everybody loves pizza. So please raise your hand if you used a new oven every time you made a new pizza. See, there's like 1 or 2. You are very rich, probably. So, but that's exactly the point, right? You're going to reuse your oven every time when you make a pizza. So that's what the Singleton pattern is all about. You create one single object, and you keep reusing that. So let's do another example. When you're eating, you have a knife and a fork. But every bite, you use that fork and a knife. But you're not going to grab a new fork and a new knife for every bite. You're going to reuse that until you finish your dish. And when you finish your dish, you put your plate in the dishwasher, for example. So see eating as a request. Right? There's a request coming into the application, and then we give a response back. But we're not going to ask for a new request every time. We're going to reuse that request until the end of the response. So in the end, we don't want to throw away your fork and knife every time. You just keep reusing that. So if we look at the definition of the Singleton pattern, we want to make sure that we always have one instance that we can cache and reuse during a request. So the Singleton pattern is a creational pattern that lets you ensure that a class has one instance while providing a global access to this instance. So, but why a Singleton pattern? So for example, when you have a database connection, you don't want to create that new database connection every time, just like your fork and knife. You're not going to recreate that connection every time. That's really slow. So instead, you create one database connection during your request and keep talking to that connection. So in this case, the Singleton pattern makes it possible to use that object and reuse that object every time. And because we reuse this object, it becomes a global object. And so we can also store data on it and reuse that. Or we can access that data in a later point in the request. So if we look at a PHP example, then we can see here that we create a singleton here by creating a private object. In this case called instance, and then we can access that object from there. So we have this getInstance method that we call, and we have a private constructor. So the private constructor is there to make sure that we can't create the object ourselves, but we can only call the getInstance method, and from there you can create the object. So this object can then be reused, and you can only call the getInstance method there. So this means that the constructor can only be invoked from that method. So this means we always have one object, right? This is the best way to create a singleton in PHP. So whenever we look at that, then we can see that they're always the same. So whenever we create two instances of the same object, we can see that they're the same. So I'm using assert same here. Assert same is also checking if they're pointing to the same reference. So that's why assert same will return true. And if you then, on that instance, call a method, that will return the same instance in this case as well. So this is just a basic example of a singleton pattern. But Laravel offers a lot of singleton patterns, but I've never seen like a getInstance method in Laravel before. So let's dive into that. So whenever we have service providers, so if you are familiar with service providers, you probably have seen something like this before. We have a singleton method here, or a call, and we're creating a new class here, and we're giving it a name. In this case, we have, for example, the DB is connected to the database manager class. However, in this case, we don't see a private constructor here. We just new up the class, and it's just using the normal constructor. So Laravel is handling all of this for us in the singleton pattern. But I don't see a getInstance method or something else here that's pointing to that PHP example. So how is Laravel doing this? So if we look at the database manager class itself, we can see just a normal constructor. And there's no private constructor here, so it's just a normal constructor. There's no getInstance method. It's not a singleton at all. So what the hell is going on here? Well, we did call that singleton method on the container, right? So there is a singleton in here. So let's dive into the container a little bit more. So here we have this singleton method, and if we call this, we can see here that we are going to bind the certain class to the certain name that we gave it. In this case, we also pass in the third argument true to make sure that we bind it to a Boolean. So in this case, we have a callback here, and we're connecting that all the things together in the API. So we have this bindings array that keeps up all the class names, and just make sure that they are in there registered in the container, so we can fetch them from there. Now the container has a way to keep up with all the registered classes in the container, just in a plain array. So this is a singleton itself as well. The container itself is also a singleton. So when it's in the container, we can resolve it from there and for whenever we need it. So if we dive a little bit more into resolving something from the container, then we first check if the instance already exists in there. So if we look at that, then we check if the instance exists, and then we return it. So then we know it's already a singleton. If it's not created yet, then we're going to make it and store it in there. And then there's one important thing, and that is the isShared method. So isShared checks if it's supposed to be a singleton or not. And if it's a singleton, then we store it in the instances array on the container, and then we know this is a singleton, so we can resolve it from there. So the instance array keeps a list of all the singletons registered in Laravel. So whenever we use the container, we always get the same instance back, because that's the first check we do. If it's in the container already and it's shared, which means it's a singleton, we return it there. So if we then look into how Laravel is doing this, Laravel is just like asking, give me a certain class, and it gives something back for you. So in this case, if you use app_make, for example, and you make the log manager, you get something like this back. But they're always the same objects, because Laravel registered them as a singleton. So the first time it creates the object, the second time it returns the same object again. And this is used throughout the whole framework, within the database, logging, hashing, notifications, authentications, and so on. But also sessions and so on. So whenever you use dependency injection, the same thing is happening here, because dependency injection is not more than just asking the container, is this class available for me, and returning that. So if it already exists there, it returns the same object. So whenever you put something in the container yourself, and you register it as a singleton, you know for sure that you always get back the same object. And if you use bind, just binding a regular class, it's going to create a new class every time for you. So this is a complete different approach to what like the regular PHP way would be for a singleton. So no private constructor, no getInstance method, no static methods in there. Laravel is handling this singleton for us. But it's still doing the same intent of the pattern, right? We're still creating one point of access to a certain instance. So now that we know how Laravel handles singletons, we can go to the next pattern, which is the observer pattern. So this is also known as the publish or subscribe pattern, or the delegation event model pattern. Really fancy words for just observer pattern, which sounds much better. So this is a behavioral pattern, and it's all about the communication between objects, increasing the flexibility to communicate between those objects, to make that better for you. So let's start with the abstract example for this. So whenever you order a pizza online, you probably receive like an email or a text message saying some information about your order, when it will be finished, and so on. But also, the pizza baker that's going to make your pizza also get notified. They get a ticket to create your pizza, actually. So in this case, there's one action, but there's multiple events triggering that. So in this case, we can call the new order a subject, for example, and then the SMS or the pizza baker is then the subscriber to that message, or to that subject. So let's do one more example. So see the observer pattern as a push mechanism. So you listen and wait for the pizza to be ready. And when the pizza is ready, the person behind the desk calls you out and says, hey, your pizza is ready. And at that point, you're going to walk there and grab your pizza and go home and eat it. You act only whenever this event is triggered, and then you retrieve the pizza. But you don't keep like asking every minute, like, is my pizza ready? Is my pizza ready? Is my pizza ready? They're like gonna think you're really annoying. So in this case, you're waiting until some event is triggered, and then you put an action to it. So when we look at the definition of the observer pattern itself, we can see here that, in short, that it brings us communication between the objects whenever state changes. So define a one-to-many dependency between objects so that one object changes state, all the dependent listeners, in this case, you as a listener waiting for a pizza, or the pizza baker waiting for a new order, that are notified, and then they can update their state. So this basically means we have an event called subject, or an observable, and that can notify multiple listeners, or also called subscribers. So if we look a little bit about terms, we have observables and an observer. So these are like the PHP terms for it. So there's always a zero-to-many relationship. Like actions can be triggered, but there don't have to be a reaction on it, but it can be, so zero-to-many. And always the observer itself, so the person that's going, or the action that's going to be performing something based on the action that happened, it's always getting that original object, so it knows the current state of that object. So if we look into code a little bit more, then we can see that here. So the same example as before, but now in UML. We have an observable interface that makes it possible to collect observers. We have an observer interface that handles the update to state of the object. So this method here, the update method, always gets the observable object here. So an observer always gets the observable object here. So if we look a little bit more into code, then we can see this, that we have an observable. So in this case, a process that's an order, a new order that's coming in. And then we can add multiple observers to that one. And then for the notify, we're just looping over all these observers we have stored in here and just call the update method on it and pass in the current object. So we know the current state of the object and just pass that in so the observer itself can handle that action. So this is the core of the observer pattern. So whenever we set up an observer, for example, we have this update method and we get an observable object in there, and from there we can perform some action. So in this case, send an SMS or go to the ticket printer and print something out there. So everything that remains whenever an action is triggered is just filling in the update method and perform some action in there. In this case, we can use dependency injection and so on in here. So the concrete implementation doesn't really matter for the pattern itself. But this code is pretty decoupled, right? So it's like just observable interfaces. It's not doing that much anymore. We can also just type it in here. So then we have a more concrete observable and a concrete observer. So in this case, the update method has been updated and it gets the current event in there. So we can see what kind of event it was, so we can actually get the state of that object. So we know what kind of method it has, what kind of properties, we can use that in our code. So you probably have already seen this stuff like when you're using events and listeners. That's the same basic thing. So if we put this all together, you get something like this. You have a new action, a new observable, and then we add observers to it, and then we just call notify. And notify is going to loop over all these observers and just call the update method on it, and that's it. So, and then the observers perform the action based on the current state of the object that we gave it. So the order process object, that's the one that will be passed to that notify method. So let's dive into the Laravel way of doing this. So if you are using Laravel, you probably all are, you probably have seen this before. You have like a list of events and listeners. We can register all events and listeners, and that's it. Note that our service provider here is extending the event service provider from Laravel itself. So it's one class that's in the core of Laravel, because they're both called event service provider. So that can be a little bit confusing. So you can see here the events as observables and then the listeners as observers. But this is just an array of observables and observers. So how does Laravel handle this for it? We're not like connecting those things, right? How does Laravel do this for it? So if we dive into this event service provider class, we can see here that we have an array of listeners, and that we collect all these events and listeners and try to put them all in one place. So in this case, we have the facade, we're calling event listen on it. You can compare this to adding the observer to the original listener, right? To the original observable. So in this case, the event facade makes sure that we add the listener to the certain event, and that's it. So if we dive a little bit more into that one, then we can see more of what's going on there. So this is the event facade class. So the dispatcher class, which is connected to the event facade. And there's a listen method here, and we pass in an event, and we pass in the listener. So as you can see here, it's building up an array called listeners, and then passes in the event, and then an X amount of listeners. So if we look a little bit closer here, then we have the make listener method, and the make listener method is basically converting the listener class that we have to a callback. So we then store that in the container. So in this case, Laravel stores all these events and listeners that are connected to each other in the container. So this is basically also a singleton. So that's all just for registering, right? So it's just registering all the listeners in the container, and that's it. Now we have an array with observables and observers, or events and listeners. But how does Laravel trigger this for us, right? How does Laravel know what to do whenever something happens? So that's why we have this event helper, or you can call it dispatch method, on the event class itself. So Laravel has this method which is calling the app events call, which is actually pointing to the same facade, the dispatcher class. And we have a dispatch method on it, and we just give it some event. And from that event, Laravel will trigger then the listeners. So this is Laravel's way of saying, hey, there's an event triggering here, perform all my actions. So this is like the same thing as calling notify on the previous object. So if we look into the dispatch method a little bit more, we can see here that we parse the event. In this case, we don't have a payload, so it's just an event and a listener. And we then grab all the listeners from the dispatcher, which are stored in there because it's a singleton, so we can just grab that data. And then we simply call each listener. And because we converted each listener to a callback, we can just call the listener object, the listener parameter. And then that's it. Then we have our callback running. So then it's performing all these things. So you can see this as the update method of the observer. Laravel is doing this for us, but it's now put into classes instead of just methods and interfaces. So this is Laravel's approach of the observer pattern for events and listeners. So this event is used for model events as well, right? This is the same thing as model events. So whenever you save something or you delete an object or a model, then whenever something happens, Laravel triggers an event and does something for you. And connecting those observer classes or observers to that model or in your boot method, that's all being the same thing. It's all triggering that. It's all putting that in the same container, in the same array, basically. So I'm not going to dive into that a little bit more. But it's still using that same dispatch class. So everything that is happening around events and listeners in Laravel is all using this dispatch class. So that brings us to the final pattern. Are you guys getting hungry already? I see some people like, oh, food. There's more food coming, so just saying. Okay, So we're going to dive into the bridge pattern. This is a structural pattern. So we have 3 types of patterns today. So this is the last type. So a structural pattern describes how inheritance works between objects. And it's about the realization of the relationships between those objects. And this solves the problem of complex composition between objects. Really fancy words. Just going to dive into examples later. But let's first do an abstract example. So let's say we have a product and promotions. So the product in this case is pizza, and we have a promotion which has a price and a name. So in this case, we have pizza and Black Friday. So if we look at another example, we can have chicken wings and Valentine's Day. So what these things have in common is that the one is a product and the other one is a promotion, and they can just independently work together. Because I can also give the Valentine discount to a pizza, right? And I can give the Black Friday discount to chicken wings. That all works. So this is the bridge pattern. So the products and promotions are both unique. They're both on their own working separately. But because they're implementing the same thing, the same parent thing, in this case a promotion or a product, they can work independently from each other. So we can also combine them and switch them out. So the bridge pattern, so if we look at the intent of the bridge pattern, it's decoupling and extraction from its implementation so that the two can vary independently. Well, this confuses the heck out of me. I have no idea what this means. This is like science or something. I don't know. So when we look at this, we have to dive into a more technical example to see what's going on. So we're going back to the UML part again. So if we look into this, then we can see that an abstraction and an implementation are both 2 separated parent classes. And then each one is differently. So we have an abstract implementation and an implementation of the implementation itself. So this is all really hard to understand. So let's dive into the pizza examples one. So if we look here, then we can see that we have a product and a promotion. And a product can have a name and a price. And then a promotion can have a certain discount and a title. But as you can see here, we have pizza, chicken wings, Black Friday, and Valentine's Day again. But we can just swap them out because that's how the UML in this case describes it. So the reason this is called the bridge pattern is because this looks like a bridge. That's it. Someone made this up, I didn't. So in this case, a product always receives a promotion, just like we see here. And then, so now we can create multiple implementations that can update on their own, right? We can create a new pizza object, and it can have a different name or a different price, but the promotion still applies to that same price. And it doesn't really matter what the promotion is, because the price is just a single value in there. So we can even add other promotions, for example, Singles Day, or we add a new product, we call it, let's see, a Subway, for example, or a sandwich. We can just add some things in there and still apply the promotions on there. So the two can vary from each other. So if we look into code, we get something like this. So we have a product, which has a constructor, and we give it a promotion, and then a name and a price. So this is just basic stuff. In the promotion, we have a method called apply discount. So a promotion has this method, and from there we can continue. Now if we look at the price method, then we can see here that we can add multiple implementations here. So we have a pizza object and a chicken wings object. And both can have different methods, but they're still looking into the getPrice method. So the getPrice method here always is the same thing. So we apply a certain discount, and from there we can keep working on it. So in this case, we have a certain class, pizza. This basically describes what the price of a pizza is, or what the price of a chicken wings is, using these different methods. So if we look on the other side, on the implementations, the promotions in this case, we can see here that we have an applied discount, and an applied discount is different for each different promotion. So in this case, we have applied discount for Black Friday, which is always, you always get 40% discount, but it's always ending on 99 because that sells better. And then Valentine's Day, you always get 25 cents off. So, but these prices can always be applied on any of the products. It doesn't really matter what product you have, you can apply it. So if we look into an example here, you can see here that every promotion is now reusable on each product. We just get different prices based on different objects that we put into there. So this also means we can swap them out. And it won't break our code, right? Because we have this interface we're talking to, so we always know we have the correct interface. So you might think, how is Laravel actually doing something with this? This is so complex. Why is Laravel doing this? Well, let's dive into that. So it all starts with migrations in Laravel. Laravel offers a database connection with MySQL, SQLite, Postgres, SQL, and so on. So Laravel applies the bridge pattern here because we can add a new database implementation without breaking the migrations, right? We can just add a new database connection there and it won't break there. So that's where the bridge pattern comes in. They're replaceable by one another. So if we look at the UML of this, you can see something like this. So we have a builder object that's building the queries for us, and we have a grammar object that's helping us building these queries for us. But we can replace the grammar with another language and then still use the builder class in this case to actually perform these queries. And then if we look at the builder class, we have some specific implementations like the MySQL builder or the SQLite builder, because some queries can't be like reused in all of the systems. Or some of the methods from the grammar can be reused in all systems or don't make sense in there. So for example, dropping tables is completely different in MySQL than in SQLite. So the grammar's implementation in this case makes it possible to perform fine-grained queries per database type. So if we look into this, we have a grammar connection getting here. So whenever we create a builder, we get a connection in there. And from the connection, we can get the grammar. And the grammar is, in this case, MySQL or Postgres and so on. This is already initiated when booting Laravel because it's already stored in the container based on your configuration. So in this case, the schema facade in your migrations is pointing to this builder class in Laravel. So that's what we saw in the UML as well. So if we dive a little bit more into the code here, then we can see here that whenever we drop a table, for example, if we look in the MySQL builder itself, we can see here that we're using the grammar, and it's calling a method called compile drop all tables. So this method can be created in all of the grammars, and they're all doing the same thing. So whenever we add a new grammar, so a new database type, Mongo maybe, then there's a way to delete that. So we just have to implement that method, and then we're good to go. So then we can swap them out. But in this case, Laravel also does extra things for MySQL because we need to disable all foreign keys. And we don't have to do that in SQLite, for example. So that's when you get fine-grained queries here. So if you look at the SQLite example, then there's a complete different set of actions, but they're still using the same grammar. And in the end, compile drop all tables is being called as well, but it's also calling some different things. So that's why we have fine-grained actions in here. So if we dive a little bit more in the method itself, you can see here that each grammar has a different query. So based on the language or based on the database implementation, you have a different language here. So the bridge pattern here helps to easily add a new database integration without having to create logic in the builder itself. We can just reuse that grammar. On the other hand, we can build multiple abstractions, so in this case builders, that can do fine-grained implementations using that grammar class. And you can also reuse this grammar class on other places because it's just queries in the end. So this makes more sense now. Decouple an extraction from its implementation so the two can vary independently. Right? We have two different systems working here and they can vary independently. We can just still change them without breaking any code. So this does look like the adapter pattern, right? But they both have a complete different intent. The adapter pattern makes two incompatible classes work together, while the bridge pattern helps you design this up front. So you already think about it before you build it, and the adapter pattern is more connecting things together that are not connectable. So let's do a quick summary. We've done the Singleton pattern, and we looked into knives and forks and using your pizza over your oven over again. Laravel uses a complete different way of setting up the Singleton pattern in your application because it's not using a private constructor or a get instance method or static methods in there. However, the concept is still the same. It's the same intent. We're still providing access to that one object that we initiated before. So you can use the Singleton pattern to keep state and only make sure that you have one instance, like a database connection, for example. So, well, the observer pattern is pretty clear. We have events and listeners, so whenever we trigger something, we want to put an action to it. So Laravel uses this in event and listeners, but also in your model events and other places where you use events. And you can use the observer pattern whenever you want to perform some action and make sure that another object is being updated based on that state. And then finally, the bridge pattern. So we have seen it used for migrations and basically queries running against a database connection. We can easily add new connections, but we can also add new queries in there and make them better. So whenever you use the bridge pattern, whenever you have multiple APIs that you want to abstract them to a single API, like Laravel is doing with the grammar class, so you can reuse that in your whole application. Note that there is no silver bullet to design patterns. Design patterns are hard to understand, and yeah, you just have to work with them and figure them out. You can just say, I'm going to use this pattern and see how it goes. But yeah, just use your common sense when applying them. And yeah, I made a lot of mistakes with this as well, so you just need to learn by doing. So there's one more thing I want to announce. I'm writing a book with Stefan about Laravel secrets, so we'll probably want to release it at the end of this year, beginning of next year. So you can all sign up here if you are interested in it. Make sure to follow us on Twitter as well for announcements. So we'll be sharing stuff as well on Twitter. So yeah, I'm very excited about this. I hope you learned something from that as well. And we'll see how it goes. So thank you all for your time.